updates from anyone around the Build Tool community outreach tracking?
No news from me. I was on vacation, but also nothing from the OCI folks. They're pretty busy still. And nothing on the MITRE side from me.
Nor from me.
I will be syncing up with Chris Short in the next couple of weeks, leading up to KubeCon, and but nothing new since a couple of weeks ago there.
Cool. All right. Well, I will head back to the agenda then.
Okay.
Reproducible build conversation. This looks interesting. I'll put a link to this in the chat.
Yeah. I know that was a really interesting kind of intense conversation back at Open Source Summit Austin. Have we moved that forward in any way since then?
Probably not yet. That's old conversation, right? So I think we have the choice to not embed GitID into the L file, that kind of thing. Or we have the ADG and the symlink farm like that. Then probably we can talk to them again, because we have the option to not embed GitID at all for reproduce build. So that will solve a lot of issues mentioned here.
If we don't embed GitOID in ELF or any output binary,
right?
We don't have the
we still record the mapping between the artifact ID and the GitBOM ADG document. So we still have everything, right? And then we can keep record that in somewhere in a mapping database. Right now we're using a symlink farm like that to persist that relationship in the file system. I will show a demo.
Symlink farm?
Yes, like that.
Okay, I'm not familiar with that phrase.
Sure. Yeah, after demo probably it will be more
the
details. Yeah. So we should be move forward with the reproduce build community with new our POC like that.
That's one of the POCs you can do today. Wanted today.
Yes.
Fantastic.
Oh, nice.
Awesome.
Anything else on this? Oh, sorry, Ava, you're leading the meeting, not me.
No, I'm perfectly happy if you want to. Either way. No, yeah, I have nothing else on this. Anybody else? Okay. Cool. Moving on then, and with excitement to see that in a demo soon.
Awesome. I think I merged this. Yep.
Yeah, you merged it. This is just saying that it was merged, and
awesome.
Tinkering with what I think is going to be the next thing, which is it's actually having a discussion with Ed about this, that right now the constructors that take a reader also take an expected length to say, hey, if the expected length didn't match what we actually read, then produce an error saying, this is fishy, something probably went wrong, you should handle this. Sort of have the question of what about contexts where there isn't an expected length, or you sort of don't want to require that the caller figure out what they think the length should be, and sort of playing around with a couple of different ideas for how that could be handled. One being sort of to make it an optional parameter, the other one being to provide in the output something that says, hey, here's how many bytes were read, and then the caller can do some checking to see if that's what they expected. So not sure which route I want to go yet, but that's probably the next thing.
The second route is kind of the hacky workaround I've been doing with, or experimenting with GitBOM RS CLI. I prefer the first option, to be honest.
Okay, that's good feedback. Okay, cool. So that's the next thing.
Cool. Anybody have news about upcoming events or conferences to share, raise awareness, open CFPs that we ought to toss something at? There, I know the IETF and IEEE have some things open up right now, or still open, and RSA is still open. I'm not sure if those are the right events for us at this time, but just thought I'd mention it.
I think we're entering the end of the year conference fatigue season.
Yeah.
But yeah.
Yeah. The challenge is that planning for next year's events is ongoing for folks who are hosting them. So we,
Of course,
if we want to get talks into the spring cycle, now is when CFPs are still open.
gotcha.
So I will try to bring a list to next week's meeting.
Awesome.
Okay, moving on to the blog post. I know that's been an ongoing thing. Chris and I started. Obviously, I was on vacation, didn't have a chance to do any work on that. Anybody have feedback or things they changed and want to just say, hey, I did a thing?
Boy, it feels like it was a month ago I did a thing. I don't know if if we had caught up on that, but I had started re-editing the intro paragraph and then actually started to rewrite like a different way that we could discuss this down below. So
okay. Yeah, I think I added a bunch of comments we can see there just after you made those suggestions.
okay.
And then I disappeared mid-September.
More work to do.
What was the sort of reframing you're talking about?
It feels like it was all like Debbie Downer. Oh man, you know, the world's horrible. SBOMs are miserable. It was like, how do we reframe this so that we can build on the fact that this stuff is coming and demonstrate how GitBOM can work together with these other tools and these other methods that are, you know, becoming prominent. So what I did was I started writing up, hey, here could be a case study. Pretend that, you know, it's December and you just learned of a new vulnerability like Log4Shell. There you go. So it was like, hey, if we reframe it this way and put yourself in the world of in the mind of a CISO and say, hey, here's how GitBOM would help you. That might be a better way to phrase all the strengths that it adds.
Yeah. The some of the Washington, DC meetings that I had hoped we could get this blog post out ahead of happened 2 weeks ago. And one of their outputs was just published, I think, Monday this week or Friday last week. And its tone was also very much Debbie Downer. SBOMs won't solve your problems. Executives, you know, CISOs and CTOs are looking at this and kind of hate it already. And what can we do? That, you know, that survey from Harvard ended up with a bunch of questions of what do we do better? And of course, I think GitBOM is part of the answer to that. So
yeah,
can
you share that paper that was published?
Yeah, I'm trying to find a link again. It wasn't, I didn't see the link through journals. I saw it through, here's a, you know, deep link embed to someone's FTP server. So I will dig that up as soon as I can and drop it into the blog post working doc.
So one thing that I've been pointing out to people when it comes to the build of materials or software build materials is that you have two general schools of thought. One of them is a very technical approach, which is like, let's try to make the SBOMs as detailed as possible, make all the links as much as we can, throw anything we can into it. Then there's a second school of thought, which is let's keep this thing minimalistic with only the things that we are likely able to test properly. And if you look at what the government has done, the US government in this scenario with their minimal SBOM elements, like they really are very minimal, but they're also the kind of things that that are considered to be high impact, so that you know where something is coming from, despite the fact they don't actually go into linking into the source or similar. And one of the things that we're finding is that the more detailed approach, because of the noise in there, is causing the cost of ingesting and validating the SBOM is at this point extremely high. And until that cost goes down, there's either marginal or negative value to being the consumer of such a system. But there's still value as a consumer to know that this package came from this specific group. So even just building that linkage there is of high value to them. And the area where we come in is that we're able to provide that tightly scoped but extremely accurate linkage of what came from where without tying in everything else. So I think that we've hit a really nice sweet spot here.
Yeah, I think that that's a really good point, and I tried to capture it in the last sentence of the first paragraph. Like, I think what our intention with this is to say, here's how SBOM formats used in concert with what GitBOM provides really gets to the heart of that vulnerability management issue, right? Keep it light, keep it small, but have that gitoid that points you back to the exact artifact that's affected.
Okay, found the link. It is now up at the top of the page. And it was Georgia Tech, not MIT. I got that wrong. Just a little bit down. A little bit more, a little bit more. Recent publications, there it is. Yeah. Yeah, so I have some concerns about the paper, some of their findings and suggestions, but there's also some good stuff in there.
Cool. Thanks for sharing.
Yeah. Published on the 30th of September. Okay. Yeah. Yeah, and Frederick, to your comment about NTA's minimum elements of SBOMs, yeah, I'm hearing a lot of the same things. People that are trying to adopt it, it's still too fragmented, too inconsistent, and too difficult to parse everything together across a whole supply chain. And even the minimum elements don't give a high enough signal to response teams. So they're very noisy and they're complex. They don't have the specificity that GitBOM would.
Yeah, and interestingly enough, it's the exact same problems we have with things like CVEs, that
Yep.
They're designed for humans to read, not for machines.
Yep.
The way that I've been explaining this to many is like that SBOM, if you can trust it, if it is relatively accurate, helps that software consumer to say, look, I think there's a match between this component and that known CVE. But it doesn't do anything for accelerating the remediation cycle that has to occur. All they can do is ask that question of the vendor a little bit faster. Now, that's good from the consumer perspective. Like, there's no argument that there is value there. But what GitBOM provides is additional value for the person who needs to go and perform that investigation, the person who owns that software.
Yeah. And it's not just at the time of downloading to ask, is this software that I have not yet installed known to contain any problems? It's the, out of the 10 million pieces of software in my environment, which ones are at risk? And even the NTA minimum elements don't get us there yet. So,
and to Frederick's point, you know, when every one of these SBOMs is how many megs and how many thousands of pieces of software you're trying to investigate,
how many gigabytes?
You can search.
Yeah, I've seen SBOMs that are bordering on a gigabyte of text.
Yeah, I can give a good example as well. So we actually had something like this happen in NPM, where they were looking at using SIG store initially for doing code signing and trying to get to that particular end. Because granted, it's not an SBOM, but I think the point will be there. And there was a strong rejection of the proposals because of the amount of work that was needed on the developer side. And that's something that I think we should pay attention to, which I think we are because of the work that we've been doing with the various compiler teams, so that it's just automatically there. But one of the things that I came to realize when I was in one of the calls and trying to provide advice there was that the important part was not the actual signing by the initial developer, but it's actually the process that is there that allows you to link to the initial source of the to the actual source code itself. And the reason that that's important is because I can have a package, and that package, I know where the source code it lives in the open source community. And if I can guarantee that that package was the input and is the only input through a reasonable process that we can defend, then what that means is that if I start from the same source, maybe Microsoft comes in and looks at it, maybe Google comes and looks at that piece, maybe Red Hat looks at it, and so on, and they all can attest to a given location that this source code has these problems, has remediated these issues in the past. And then I know that if I start from there and I run it through my build system, that I can at least start from a place of knowledge. And it's not about the developer signed to this. It's about this was the state that we analyzed it in, and we're able to guarantee that it followed a secure process to reach my destination. So that one was a bit more received as well because it required no change from the developer side, but it still had somewhere that's actionable that can still have a meaningful change in the open source community when resources are spent to try to defend it.
Okay, I'm gonna time check us. We do have 2 demos and about half an hour left. And I would love to come back to this if there's time after the demos, but I'm really excited to see Yonghui's demo of Simlink Farms.
Should we move to the demos, or should we discuss the call for volunteers to help with social media?
Are there anything specific on that, or yeah, that go ahead, Nell. I don't know what that.
In that regard, I've put the recording in the YouTube GitBOM channel. So should I? If anybody is going to just post it on Twitter, I don't have a Twitter account, so I can just let you know once the recording is uploaded, and somebody else can just take care of sharing that in Twitter.
Yeah.
Okay.
Sounds great. Yeah, just drop a link in the Slack for us. I think Ed and I both have access to the Twitter account right now.
Okay, sounds good.
I'm not sure who else does. And I'm going to move that up for next time. We do tend to copy our agendas from the previous ones, so that'll change it for next time. And with that, Yonghui, would you like to take over the screen share and do a demo?
Let me share my screen. Share. I need to, let me see. I cannot start screen share while the other participant sharing.
Let me stop sharing.
Yeah.
There we go.
All right, thanks. Let me see. I need to, okay. Sorry, I need to, okay. All right. Can you see my shared screen?
Yes, we can.
Okay, good. So basically today I show a demo for two things. One is the GitBOM build, where environment variable, and the second one is the symlink farm to persist the artifact ID to ADG document mappings. First one is for this configurable build, GitBOM build with the environment variable. So basically I define an environment variable called GitBOM build mode like that. We can stand as a name. Then I have a few attributes to turn on, turn off each feature like that. So for example, I can specify whether I generate SHA-1 or SHA-256 or both on the hashing we will use to embed or generating the GitBOM document. I can specify whether we want to create ADG document or no ADG. We can embed BOM ID into the L file or not, or any archive file, like everything. We can record the raw hash without creating ADG. These are just some attributes of feature we can turn on, turn off where this single environment variable. The details of those I have put into this spec 22, number 22 issues. Basically, let's talk about the record hash mode. So this is just for the software build. Basically, we just record every relevant build step when that relevant build step change the binary hash, for example, from source to intermediate.o file, or from intermediate.o to the hello binary, or some strip symbols to generate a new binary file. So for each step, we just need to record the out file hash and list the in file and their hash. So this is the minimum information we need for our software build, actually. If we have this information, we can reproduce or recreate all the GitBOM documents like that. So we have all the information for your software build, actually. This is basically what's happening for your software build, changing, transitioning, converting from your .c source file to the final delivery binaries. So here it's just an example GC, first compare to .o, then linking to Exable. Similarly, we can do it in 3 steps. That's fine. For each step, we just record the basic information. This to .c to .s, and from .s to .o, and .o to Exable. Adding more, we add the strip operation. So you can see here we have strip, same in file, out file. We just record the basic information of the hash. So to be more generic, this record hash mode can be extended to record metadata mode, not just hash. We can record more information for your software build. For example, this more information, CV, vulnerability, anything you want. We can use the more configuration file to configure what information to record. The good thing about this thing is that it's not intrusive to your build system. Usually this is just some extra operation workload that you will do when this is configured. If this is not configured, then everything is same for your soft build. Next is for the symlink. So I think we have some discussion around whether we want to embed or not embed GitOID into the output artifact file. We see some value in not embedding BOM ID into the output files. So this symlink farm idea is to record this artifact to the GitBOM document mapping when we don't embed GitOID into the output file. So basically, we every time after we generate the GitBOM document, we create a symlink from the output artifact ID to the just created GitBOM document. So this way we have in our file system, we have a mapping from artifact ID to the GitBOM document ID, the BOM ID. So that for user, even if there's no embedded GitHub ID in the L file or artifact, we can use this symlink to easily find out the real GitBOM document that's correspond to the artifact ID. Yeah, I will show the demo for that. Yeah, so I have modified the GC and the LVM clone compiler with this support of a GitBOM record hash mode and this variable configuration for the features. Also, I modified the bin utility, the program, the strip, obj copy, AR runlib to support this new mode. Yeah, next I will show the hello world example for this feature. So here you can see my terminal, right? So I have some .c file here, just and a make file, just compare these things into either a archive library or just executable. So you can see I configure this. This is just GitBOM build mode. I still use the record hash mode, but it's already configurable for different features. So you can see I have SHA-1, SHA-256, create ADG, record hash, embed BOM ID. That's current configuration. This is just a location that we can configure where we want to put the GitBOM document, symlink, the record hash location. If without this one, it's just a default location. So with this, we should be able to generate the both SHA-1 and SHA-256 hashes for the GitBOM documents, and we'll create the AD documents and also symlinks. We'll record the hash. We'll also embed BOM ID into L file. So let me see. I can rebuild just this one. Maybe easy one. A simple one first. Let's see. Yeah, this one is just compile two .c file into a single executable. So let's do this. This is easier. So when we do this, you can see basically this is we first embed SHA-1 BOM ID into this .o file. That's actually just a template file. Also, we embed SHA-2 because we are configured to do that. But this SHA-2 just SHA-256. So this first, I think this function 2.c. And the next is just embed the same thing for the hello 2.c to the hello 2.o. We embed SHA-1 and SHA-2 BOM ID into this .o, and then we record the SHA-1 hash. We also create a GitBOM document and symlink. Same thing for linking step. We embed SHA-1, SHA-2 into the hello2 directory. We also create the GitBOM document and symlink, and also record the hash to some files. Let's see the result. The result I put into this single location. So you can see. So here in the GC directory, I have the ADE document, all the ADE document put here. So this SHA-1, this SHA-2. Also, I create a symlink directory, put all the symlink farm here. So you can see this is the artifact output artifact ID, and I have symlink. Yeah,
it's very hard to read that font color, like a light blue on a white background. Sorry.
Let me turn off the color, I think. Yeah. Now it should be gone.
There we go. Thank you.
Okay. So you can see for the symlink, it's just some this artifact ID. I add a suffix here. Whatever format we can specify in our GitBOM spec. So basically, this artifact ID, then it pointing to a location, I mean, the GitBOM document we created. So each SHA-1 or SHA-2, you can see here we persist the artifact ID to the GitBOM document mapping in this file system. So basically, for each output file we generated, we immediately create this symlink. So I'd actually suggest we always create this symlink by default, because even if we embed BOM ID into the L file, this is still useful. Actually, this makes the artifact to BOM ID mapping more efficient, I think. You don't need to look up the BOM section, passing the ELF section, right, to extract the BOM ID. You can easily just through this symlink, you can find out your GitBOM ID. Yeah, so this is the symlink that we're talking about. Yeah, this is just one very small extra work we added, but it will be able to persist the mapping. This means that for the reproduce build,
I think Ava is trying to break in.
Sure.
Yeah, sorry, Yankwei,
Go ahead.
did you say that there this is written up somewhere in a
Oh,
pull
yes.
request or a spec proposal or an issue?
Yes, so you can see here this slide
Awesome.
proposal to using this symlink to record the this thing artifact ID to BOM ID mapping. So here, right? So I'd suggest that we always
Fantastic.
create this symlink for by default.
Great,
That's
thank you. I will note that. I have the link to
Yeah.
that in the notes.
Yeah.
Were there other things you wanted to show in the demo, or should we move to discussion?
Yes, this is what else? So now, right, you can see this Hello 2. I will show you the BOM2 Hello 2. It has this ID, right? This SHA-256 ID. I want to show you this more. Yeah, this is the basic one. You can see exactly what's happening here, right? So here I have more complicated release. This involves some archive. So not just GCC, right? We have other tools, for example, archive, or runleaf, or strip, that kind of thing. I have modified them to, you can see this is my modified version of the bin utility tool. So I will show you how, yeah, this one, let me change this one to just, I think, yeah, this one. So now you see, well, this we have a lot more, right? You can see we have the archive thing, this OBJ copy thing, this archive thing. So you will see, yeah, this is a thing that happened, I think, yeah. So let's see this one, yeah. So you'll see that this is a recorded hash file. So with this record hash mode, you will see basically what's happening in a software build. For each step, each build step, you have the build command, you have the out file, and list in file for all the GC command. This GC command, this is the OBJ copy command, same in file, out file. And when you have this thing, you are very clear what's happening for your software build. And we can actually, for example, in the record hash mode, we don't need to generate any ADD document or do the embedding of BOM ID into L file. We just have this raw information. Then we are able to just post-process this list of recorded hashes, right? Then we'll be able to create the whole GitBOM document and the BOM ID. This is something that we call the record hash mode. That's actually it records the equivalent information as the GitBOM document and the symlink to persist the artifact ID to BOM ID mapping. That's the equivalent information. Next, I want to show you. Yeah, let's see.
Just we're at about 15 minutes, so if you could
okay, yeah, let me
start to wrap up soon.
Yeah, I will wrap up. So I already have done some performance measurement for this configurable GitBOM build mode. You can see this is open SSL build. Yeah, so it's basically about 2,500 object compilation with GCC. So I'm using just make J8 to do the build. So you can see if we do nothing, just unset this build mode, then it's the same as before, right? Nothing GitBOM related. So just 1 minute, 18 seconds, right? So if we do record pass only, no hash, this is just record hash mode, but we don't do the SHA-1 or SHA-2 physical hash compilation, just record the file path. So this is a very minimal.
Yonghui, I don't think we have time to step through every line on.
Okay, sure. This is just to show you an idea.
It's great to have a performance comparison. It really is useful to see.
Yeah,
but we don't have to step through every line.
Sure, no problem. Yeah, this is just for you, so you have an idea. So basically, my demo is done. The two ideas, I think we already have that.
So we do need to get time for Vojislav to give a demo, but I do want to ask a question to Frederick, who's here on the call, seeing this. This kind of tracing of in-file to out-file looks very similar to a project that I think got submitted to the CNCF a few months ago. Is that right?
Are you talking about Witness, or is there something else that you have in mind?
Witness, that's the one. Yep. Thank you.
Okay, so there are similarities here. What Witness is doing is it's using some form of operating system construct, usually something like strace or eBPF or similar, so it's pluggable, to scan not scan, but to trace every interaction that the process has with the kernel. So basically if we can capture the system calls, you can then work it and stick that into some form of attestation. Then that gives you the ability at a later time to determine whether or not it meets your policy today, or even meets a new policy that you decide to build in the future, as long as you've captured enough data. The stuff that is going on here, I think, would be complementary to that, because Witness itself is designed to be pluggable in such a way that we could add this as a possible backend. So I think that there's definitely some overlap here, because we are capturing some of this information as well. But there's no reason to. But I do think that there's complementary functionality here as well.
Fantastic. I'm glad to hear that it is not duplicative, but could be plugged in as a backend. And yeah, this is using strace under the hood as far as when I last looked. Cool. Thank you, Yonghui. Let's shift over to Vojislav.
Thank you. Let me stop sharing.
Okay, I will share now. So this is just a short demo to show what was done since the last time I presented in GCC 11.3 regarding recording GitBOM information. So currently I'm in a test directory with two test cases, A.C, A.H, B.C, and B.H. We will focus here on A.C and A.H. So as we can see, A.C contains the include the directive for A.H and stdio.h, which also means that there are a lot of dependencies here, which will show now, and A.H is just simple one static long A equals 10 definition. So what was done since last time is the implementation of the GitBOM dir environment variable, which accepts both relative and absolute paths. So here I give it a relative path, which is GitBOM dir. And now if we want to run the compilation of this a.c, notice that we don't have to mention -f record -gitbom option, because by the spec, per the spec, when you set this environment variable, it should be enough to record gitbom information. -md is not necessary, as we will see later, but here I want to see what the dependencies are. And what we got is a.d, obviously because of the -md, a.o, and gitbom dir directory, which is here because we set the gitbom dir environment variable to that value. So if we just quickly look at a.d, these are all the dependencies that are pulled when using a.h and stdio.h. In gitbom dir, we can see that there is a .gitbom created folder. In that there is objects. Also, this is all by the spec and the same as in the LLVM. Then D5, which is the first two hex characters of the 40 hex character gitbom document file name, and this is the gitbom document file name. So this is all that was already there, but there are some improvements as it is in LLVM. So this is the gitbom document file. This line was added because currently SHA-1 is used to calculate the gitoid hash. This can be obviously like SHA-256 or whatever once that implementation is put in GCC as well. These are the sorted hashes and gitoids of these dependencies here. I mean, I manually checked them all, so it is that I don't want to bore you with checking each one. So I went too far. So this is this gitbom dir directory, and also we have obviously a.o, which we can see that contains .bomb section with that hash, which was not there previously. So this is new. In .bomb section, there is that gitoid of the gitbom document file, and as we see here, it is D57F, something like that. It is D57F, etc. So it should be there. Previously, the first version had a 40-byte .bomb section because there were some issues with ASCII. It took double the size, but I made it to be 20 bytes. It is of type proc bits, not SHT node, because GCC doesn't currently have that in the compilation step. But when going into the LD tool in binutils, I think we will make this section of type SHT node. And just to show this as well, so we can see now that this hash, this gitoid is put in the .bomb section. So this is the basic functionality. What was also done was that I will just remove this so that we can see the difference. So we have a clean directory as well, and when we can do this too. So in -md we don't need anymore. We can put frecord gitbom with equals to specify the directory to put the gitbom document file in this way, but it does not have currently the precedence over the environment variable, which is, I believe, so far, to my understanding, how we are doing now, but is up for debate. So that can be changed easily if we decide that this way should have the precedence over the environment variable gitbom dir. So here we can see all this is ignored because we already have set the gitbom dir, but if we unset it, so just to check. We and now run. So let me just remove everything. So when we now run this, we get because this is GitBOM Tier 1, we can see that here we have GitBOM Tier 1, and obviously everything is in it now. I said absolute paths are also fine, but let's not waste time with them right now. So this works like that. If we don't set here anything and we don't have the environment variable per the spec, we will get GitBOM information, but in the directory where .o file is created, so it is here .gitbom, just not this layer of in hierarchy of directories. And also, if we don't specify anything, right, we don't have, obviously this is just a plain compilation, we don't have any GitBOM information, right? So no .bomb section. So this is in essence what all the functionalities that were proposed to my knowledge so far for the compilation step. I'm currently writing tests in GCC, which proved to be a little bit more challenging because the test suite works a little bit more. It is a little bit more complicated, and it works a little a bit more different compared to LLVM, but that should be done soon, and then we can have a first patch in the gcc-gitbom directory. After that, the focus will be on LD and linker side of everything. This is what I prepared for now.
Looking awesome.